All right, we are still looking at data manipulation language, and we'll finish that today. So we have done DML statement is executed when, one, you add new rows to a table, which we have done by using the insert statement. Two, modify existing rows in a table. We have also done that by using the update statement. Now, today we want to look at removing existing rows from a table, which is delete. So that is what we want to look at. Now, this is the syntax for delete statement. Very simple. You can remove existing rows from a table by using the delete statement. Delete from table, where condition. So you can see that this from is in the square parentheses. I told you about this square parentheses means optional. So you can say delete table, or you can say delete from table. That's why they are putting this in square bracket. Then you have the where condition. So you can equally say delete table without putting a condition. That is why this is also in a square bracket. Now, specify rows are deleted if you specify the where clause. Specific rows are deleted if you specify the where clause. But if you don't specify the where clause, that means you want to delete everything from that table. All rows in the table are deleted if you omit the where clause. So that is just the condition there. Yeah, so this is very straightforward. Then you have database transactions. A database transaction consists of one of the following: a DML statement that constitutes one consistent change to the data, one DDL statement. We'll look at this DDL today too, data definition language, one data control language statement. A transaction consists of a collection of DML statements that form a logical unit of work. Then you have database transactions, start and end. Transactions begin when the first DML SQL statement is executed, and a transaction ends with one of the following events: a commit or rollback statement is issued, a data definition language or data control language statement executes automatic commit, the user exits SQL developer or SQL plus, or the system crashes. That is when a transaction ends. So a transaction is like saying you are transferring money from one account to another account. So one account to be debited and another account to be credited. Now, you cannot debit an account and not credit an account. If you debit an account and there is a failure in crediting the other account, then the whole process will be rolled back. So that means a transaction is not complete. Just like when you go to ATM to withdraw money. You know, when you go to ATM to withdraw money and you punch, then the machine will roll and then it will tell you unable to dispense cash. Sometimes you will receive an alert of them debiting you, and after a while they will reverse it. So because the second leg of the transaction wasn't completed, so when you receive the alert and then the second leg wasn't completed, meaning the ATM didn't give you money, so it is expected that automatically there should be a rollback. So your account should now be credited, and that is what usually happens. So it means that there was no complete transaction. So, but if there was a complete transaction where you are able to remove the money from the ATM, then your account will be debited. So there's a credit account, there's a debit account. That is the meaning of transaction. And that transaction occurs in the database. So that is, for like in the, what we have been doing now is we are using Oracle SQL. So Oracle server controls the database and maintain data consistency through the aid of a transaction. Are you with me? So, you know, we are concluding now. So I am now showing you in summary all what we've been doing, where it leads to. When you access a database, what you are actually doing is you are either reading from a database or you are writing to a database. You read from a database by using the select query, which we have used very much. And then you write to the database either through the insert, the update, or the delete, which we are going to look at today. So these are the two things you do to a database. You read from a database and you write to a database. If you don't save money in the bank, you can't go to the bank to withdraw. So those are two ways. So the bank is like a database. You put in your money and then later you go back to withdraw. That is basically the concept. So what we have been doing now is using a database, learning a language that enables us access a database to pull out data and then to put data in. So we've been learning how to read data from the database using a select query. Now we are inserting data, we are updating data, and now we are going to delete data from the database. So that is basically what we have done so far. And that is what the language is all about. And I believe that is what the general language, even this English language we are doing, is all about. So what I have been doing with you using English language is imputing data into you. And then when you go to a place and there's an issue and you need to use those data, so you are simply going to call those data, which is reading from the data and then using it to execute any task. Right now, I'm writing the data into you. That is what I'm doing. So that is basically what we've been doing, and that is what a language is for. So we are going to conclude very soon. Now, let's look at the last part. So which is the delete, remove existing rows from a table. So this is the delete syntax. Now practically let's see it. Now let's just select our table. And let me show you, last time we created a table, and if you look at this place, you will see that table. Look at, we created emp. Initially we had only countries, departments, employees, job history, jobs, location, region. So I created this emp when I was doing my update in order to show you certain things. So today I'm going to delete from this emp, right? So I will say select star from emp. And now I'm reading from the database. So I query and the emp is showing me information just like my employees table. But the last time we updated the salary column of this emp table and made everybody to have the same salary, which is 10,000 naira. Okay, so today I'm going to delete some employees. So I'm going to use the delete command. So I'll just simply say delete, right? Now, two options. Either you can say delete from emp, or you can simply say delete emp. But let's do this delete from emp. That sound readable and interesting to the ear. So delete from emp. Now, if I do this and I terminate, that is what that syntax was telling you. If I execute this, it's going to delete everything that is inside this employee table, but the table structure will remain. What I mean by the table structure will remain is like saying you are packing everything out from a particular room or from a particular house. You did not demolish the house, so you pack everything out of the house, but the house is still standing. That is what this delete does. Now, if you want to pack everything out of the house and then demolish the house, it's a different command we are going to give, and we probably will see that again today. That is a data definition language we will use to achieve that. So this delete is only packing things out. So when I say delete from emp, if I don't put a where condition, it's going to delete everything that is in this emp. First, let me add a where condition. So where I will now say, okay, let's delete. I will need to use this table for another thing. Let me delete from the employee table. So delete from employees. I think we created this. Okay, yes, we also created this Joseph Okon. Yeah, so I want to delete it. Now I'm going to say delete from employees. So you see, I'm moving to another table, to the main employee table. Delete from employees, where I will now say employee ID underscore ID equals to 207. I want to delete this Joseph. So delete from employees. I'm using the primary key. We might have two Stephen, and you will not know. So we might have two first name Stephen, And when I say delete from employee where first name equals to Steven, it's going to delete the two of them. Whereas my intention was to delete a particular Steven. So it's always advisable. Otherwise, I will have to combine two columns that will give me a unique key. Meaning no two columns will have the same data in them. Then I can use those two columns combined to delete. But the easier way is to use a primary key column, which is the employee ID in this case. So delete from employees. Let me separate this so I see. Okay, delete from employees where employee ID equals to 207. So I'm just going to execute it. So I will execute. The error was encountered performing the requested integrity constraint. Okay. Child record. Now it's not allowing us delete this because there's a child record. So there's a link between this table and another table. Integrity constraint violated. Child record found. Attempted delete a parent key value that had a foreign dependency. Delete dependency first, then parent or disable constraint. Now, let's see if we would be able to disable that constraint. It's just like saying we have the executive, we have the judiciary, and we have the legislatures. So these people are doing different things to keep the country running. Now, I'm trying to delete a particular employee, and it's telling me that a child is found. So if I come here, how do I find the other object? First, this is a table. Now, if I click on that table, which is the employees table, this one, and I come here, this is the constraint. You can see all this tab. I have columns, I have data, I have constraint, grant, statistics, trigger, and all that. So constraint. Now, when I try to delete that employee, look at what it showed me. Now I try to delete it, it's giving me this error, and this is the integrity constraint HRJ history underscore M underscore FK violated. So let's see that constraint. Job history, and then we click on constraint. You see now, why is he having this? How come he is having this? How did he produce this child history? You remember that I told you when in one of our training. So let me just now you begin to see how the database is linked. Remember that in one of our training I told you that anytime you do, so this employee is employee 207, right? Now let's look at this job history. Now when you look at this job history, look at data. Now look at this. Can you see? Look at this employee 207. In one of our training, we changed the job ID of the employee. And when we did that, the system automatically created this job history. The system automatically created this job history. And that is because there is a trigger. A trigger is like a trap, a trap in the house that you set to catch a rat. And then you put food on top of it. And you are saying that once that rat climbs on top of it to pick the food, then there should be that snap. Pa! Now that is like a trigger. That is a trap. So a trigger is, you put a trigger in the employee table saying that once there is a change in a particular column in the employees table, this job history should be updated. So in one of our lecture, we changed the job ID. We changed the job ID, right? Now look at the trigger let me show you something. Now look at the trigger. Look at the trigger. Now just follow me. You will still be able to get it. Look at this trigger. This is a trigger, job history. And if you look at this place, I'm showing you all of them again. When you look at this place, we have tables, we have views, we have indexes, we have packages, we have procedures, functions, queues. You can see these are other objects. Other object. Now we have a trigger. So what happened is that this trigger, this is it. This trigger is attached to the employee table. What this trigger is saying is that, look at this trigger. There's a trigger here and it's enable. Now I can now go to the trigger here to look for it. Look at this trigger, update job. Look at it here, update job. If I click on it, I will see the inside. Now, look at it. This is not SQL. Are you with me? This is PLSQL, Procedural Language SQL. Now, SQL is a query language that enables you to read from the database. It's a query language that enables you to read from the database. I am now bringing a lot of things in this class, but no problem. We have done enough lecture for you to comprehend what I am saying. SQL is a query language that enables you to extract data from the database, read data from the database. But there is a time in which you also want to, like a programming language. So SQL is not a full programming language. It is a query language. But to enable SQL function as a full programming language, there is another language that is added, and that is called PLSQL, which is Procedural Language SQL. So this Procedural Language SQL is working together with SQL to enable SQL have the capability of a normal programming language. So this create or replace trigger, and then we write all these things that you're looking at like this, is PLSQL that is being called now to work with SQL. So a PLSQL is used to write a trigger that is attached to a table. Are you with me? So when we change that employee job ID, this is the trigger that automatically created the job history. So you can see inside this place, it's saying create or replace trigger, update job history. After update of job ID and department ID on employees, you see. So once you change the job ID and you change the department ID of any employee, this trigger will automatically launch. And what is this trigger supposed to do? This trigger is going to call T. You see this thing that you're looking at is a procedure. A procedure is an action event. So you are calling a particular person to carry out an action. So you can see that inside a database, there is so much complexity that is going on behind the scene. Now, I'm just giving you a glimpse into it. Now, this is the function add underscore job underscore history. And then you supply this parameter to it. This function now, I am also going to show you, is a procedure, add underscore job underscore history. Now, if you look at it here, look at this place, procedure. When you expand it, can you see this? So this trigger is calling a function and then supplying parameters to it. What is the parameter it's supplying? It's supplying the old employee ID, old hire date, and then it is calling 6date. I also showed you this. So he's using this now to insert this person now. This is a person. This add job history is a person that is automatically going to insert into the job history table. So this trigger is the one that call it to execute that task. So this trigger is another person, another being. This procedure is another being. So you can see how this job history table was updated. The moment we change the job ID of the employee, this trigger activated. And when this trigger activated, it's called a procedure. And this is the procedure, add job underscore job underscore history. And this is the procedure. Now, when you open inside this procedure, look at the inside of the procedure. See, the procedure is expecting these parameters. Do you get me? So I'm not explaining, I'm just explaining this procedure to you. This is a completely different language on its own. Completely different language. PLSQL. So this procedure is going to now insert, can you see, is calling the SQL query. So the same thing I told you, when you look at a normal program, like it's a normal software that, for example, you go to the bank and you see the cashier sitting down in front of a computer or his computer. What that teller is doing is that they open a software and then they are working on that software. They don't understand this language. It is the software that they are looking at that they understand, which they've been trained to use. But every data that they input into that software is going to use an SQL language to now put those data into the database. Now, for that to operate effectively, there are so many programming languages that are involved. but you are not seeing it. Now, because of this delete lecture now and the error we encountered, I am now opening you up to see behind the scene the activities that are happening inside the database. It's complex. It's not something you just learn within a few hours.